Universe simulation theory. What if the world around you, the solid ground beneath your feet, the starlit sky, and even the very thoughts firing in your brain are not fundamentally real? What if our entire, sprawling 13.8 billion-year-old universe is nothing more than an elaborate construct, a temporary illusion? This isn't the opening to a science fiction novel, it's a question being seriously debated at the highest levels of theoretical physics. We are talking about two of the most reality-shattering ideas ever conceived, the simulation hypothesis and the bubble universe theory. Both point to the same terrifying conclusion. Our existence is fragile, finite, and potentially a complete fabrication. Let's start with the simulation hypothesis. Popularized by philosopher Nick Bostrom in his seminal 2003 paper, the argument is deceptively simple and logically terrifying. Bostrom proposed that one of three propositions must be true. 1. Civilizations almost always go extinct before reaching a technological stage where they can create ancestor simulations, that is, hyper-realistic simulations of their past. 2. Civilizations that reach this stage lose interest in creating such simulations. Or 3. We are almost certainly living inside a computer simulation. The logic is a numbers game. If a civilization can create one of these simulations, they won't just create one. They'll create thousands, millions, billions of them. For every base original reality, there would be countless simulated realities. Therefore, statistically, it is overwhelmingly more probable that we are in one of the simulations than in the one single base reality. It's the ultimate cosmic needle in a haystack, and the odds are stacked against us being the original. This idea transforms our understanding of existence. The laws of physics? They're just the programming, the underlying code that governs our simulated world. The speed of light? That's simply the universe's processor speed, the ultimate refresh rate. The pixelated nature of reality at the smallest quantum level, the Planck length, could be the literal resolution limit of the cosmic computer screen we're living on. Then there's the equally unsettling concept of the bubble universe. This idea springs from a cosmological theory called eternal inflation. The theory suggests that the Big Bang wasn't a one-time event. Instead, imagine a vast cosmic ocean of space-time that is eternally expanding or inflating. Within this meta-universe or multiverse, certain regions can stop inflating and form stable pockets, like bubbles forming in a pot of boiling water. Our entire observable universe would be just one of these bubbles. And here's the kicker. Each bubble could have radically different laws of physics, different fundamental constants, even different dimensions. In one bubble, gravity might be 1,000,000 times stronger. In another, atoms may never have formed at all. We just happen to live in a bubble with conditions just right for life as we know it. This makes our universe feel less fundamental and more like a lucky roll of the cosmic dice. While these ideas sound like they were ripped from the pages of modern fiction, the questioning of reality is one of humanity's oldest philosophical traditions. Plato, over 2,000 years ago, gave us the allegory of the cave, suggesting we might be prisoners watching mere shadows on a wall, mistaking them for the true forms of reality. In the 17th century, René Descartes pondered whether an evil demon could be deceiving him, creating a complete illusion of the external world. These ancient thought experiments walked so that modern physics could run. The scientific revolution, ironically, is what gave these ideas their modern power. The discovery of quantum mechanics shattered our classical deterministic view of the world. It revealed a universe that is fuzzy, probabilistic, and deeply strange. At the quantum level, particles exist in a cloud of possibilities until they are observed, suggesting that reality itself might be participatory, that consciousness could play a role in collapsing possibility into actuality. This bizarre behavior is much easier to comprehend if our world is a simulation, where resources are only rendered when a user, an observer, is looking. Why would a simulation waste processing power on a particle's definite state if no one is there to see it? This is the ultimate form of computational efficiency. The vastness of space and the mind-boggling complexity of cosmology, once seen as proof of a grand physical reality, now provide the very canvas upon which these new theories are painted. The idea that our universe is just one of many or a simulation among billions suddenly doesn't seem so far-fetched when you're already dealing with concepts like infinity, dark matter, and the birth of time itself. These are not just fantastical ideas anymore. They are serious considerations, logical extensions of where our best science is pointing. But are they just theories, or is there actual, tangible evidence that our cosmic bubble is real, and more frighteningly, that it's about to pop?
Proof and the pop. If our universe is a fragile fabrication, a temporary bubble in a cosmic ocean, you would expect to find clues, scars, glitches in the matrix. And that's exactly what some scientists believe they have found, hiding in the oldest light in the universe. We're talking about the cosmic microwave background, or CMB. This faint, pervasive glow of radiation is the thermal echo of the Big Bang, a baby picture of our universe when it was just 380,000 years old. It's remarkably uniform, but it's not perfect. It's modeled with tiny temperature fluctuations that eventually seeded the galaxies we see today. And within these fluctuations, there are anomalies so strange, so statistically unlikely, that they defy easy explanation. There's the infamous cold spot, a region of space that is inexplicably larger and colder than anything the standard model of cosmology can account for. Some cosmologists have proposed a truly shocking explanation, that this cold spot is a cosmic bruise, the remnant of a collision between our bubble universe and another one in the distant past. Then there's the axis of evil, a bizarre alignment of the largest patterns in the CMB with the plane of our solar system. This makes no sense. Why would the largest structures in the entire universe have any connection to the orientation of our little planet? It's a profound violation of the cosmological principle that the universe should look the same in all directions. Unless, of course, our reality has a defined structure, an underlying architecture, or a boundary that is imposing a certain directionality. It's the kind of statistical anomaly that, in a simulation, might be a rounding error or a subtle artifact of the system's design. The evidence doesn't stop there. Consider the holographic principle, a mind-bending concept born from black hole physics, proposed by pioneers like Gerard Tooft and Leonard Susskind. It suggests that all the information contained within a volume of space, every star, every planet, every single atom, can be described by the information encoded on its two-dimensional boundary. Think of a security hologram on a credit card. It's a 2D surface that projects a 3D image. The holographic principle suggests the universe might work the same way, that our three-dimensional reality is merely a projection of information stored on a distant two-dimensional surface. our 3D world could be a grand illusion, a cosmic hologram. This sounds eerily similar to how a computer stores and renders a 3D world from 2D data bits on a hard drive. Perhaps the most compelling argument, however, is the one that troubles physicists and philosophers the most: the fine-tuning of the universe. The fundamental constants of nature, the strength of gravity, the mass of an electron, the speed of light, are exquisitely and precariously balanced for life to exist. If you were to alter the strength of the strong nuclear force by just a tiny fraction, stars would either burn out in seconds or never ignite at all. If gravity were slightly different, the universe would have either collapsed back on itself moments after the Big Bang or expanded so rapidly that no galaxies could form. The universe appears to be balanced on a razor's edge, with its dials tuned to the precise values needed for complexity and consciousness to emerge. This presents us with a stark choice. Either we are the beneficiaries of an absurd, incomprehensible stroke of luck, or our universe was designed. And design, whether by a creator or a programmer, implies a purpose and an architect. So, if our reality is this fragile, what happens when it breaks? What does it mean for the bubble to pop? In the context of the bubble universe, the pop would be a catastrophic event known as vacuum decay. Our universe exists in a false vacuum state, stable but not the stable state possible. If a small region of our universe were to tunnel into that true lower energy vacuum state, it would create a bubble of true vacuum that would expand in all directions at the speed of light, obliterating everything in its path and fundamentally rewriting the laws of physics as it went. We would never see it coming. One moment, reality as we know it exists; the next, it's gone, replaced by something utterly alien. In a simulation, the pop could be even more direct. It could be the moment the simulation is shut down. The plug is pulled. The experiment is over. Maybe our cosmic hard drive is full, or the beings running the simulation have simply grown bored. Or perhaps the pop is not an end, but a transition. It could be a system reboot, an upgrade to Universe 2.0. Or it could be the moment we wake up, the end of the game, where we are pulled from the simulation into the larger, more complex, and perhaps terrifyingly real universe that created it. This isn't just an intellectual exercise. It reframes the very essence of our existence. It suggests our reality is not the bedrock of all things, but a fleeting, temporary state. Every discovery, every work of art, every human life is playing out on a stage that could be dismantled without a moment's notice. So the next time you look up at the night sky, ask yourself, are you looking out into an infinite, fundamental reality? Or are you just looking at the beautiful, intricate pixels on a screen, moments before it all goes dark?